Deep within the vast expanse of the Atlantic Ocean, a powerful and mysterious system operates, hidden from the view of most people on Earth. Beneath the rolling waves and stretching from the icy Arctic to the balmy tropics, this system is constantly at work, shaping the very climate and life on our planet. This is the Atlantic Meridional Overturning Circulation, or AMOC, a name that may sound technical, but its impact is anything but abstract. The AMOC is a vast, hidden current that acts as Earth's circulatory system, pumping life-giving energy around the globe. It is a conveyor belt of water, moving warm, salty water northward at the surface and sending cold, dense water back southward in the deep ocean. This movement is not just about water. It's about moving heat, nutrients, and even carbon, redistributing them across continents and oceans, and supporting a web of life from the smallest plankton to the largest whales. For centuries, the AMOC's steady flow has shaped civilizations. It has influenced trade routes, migration patterns, and the rise and fall of empires along the Atlantic's edge. Its warmth grants Western Europe its famously mild climate, making it possible for lush forests to thrive and for people to enjoy temperate weather, even at high latitudes. For millennia, this ocean engine has quietly supported life and prosperity. But now, scientists are detecting troubling signs that this ancient system is under threat. Using advanced technology and decades of data, researchers are piecing together a story of change. The AMOC's once steady rhythm is faltering, its currents slowing and becoming less predictable. The ocean's patterns are shifting in ways we are only beginning to understand. Evidence from ocean measurements and climate models suggests this system is weakening, raising alarms among climate scientists worldwide. If the AMOC continues to slow, it could disrupt weather patterns, intensify storms, and threaten the delicate balance that has sustained our climate for thousands of years. Understanding the AMOC is no longer just a matter of scientific curiosity. It's a global imperative, crucial for predicting our future and preparing for the changes ahead. In this video, we'll dive deep into how the AMOC works, why it's under threat from climate change, and what its potential slowdown could mean for weather, sea levels, and life as we know it. The consequences of a weakened AMOC could be profound, affecting millions of people and ecosystems around the world. It's a story that touches us all, whether we live by the ocean or far inland. The story of the AMOC is the story of our planet's fragile balance, one that we may be pushing dangerously close to the brink, as melting ice and warming waters threaten to tip the scales. The ocean is sending us warnings in the form of shifting currents, rising seas, and changing weather. Our future may depend on whether we listen, and how we choose to respond to the planet's great ocean engine. Picture the AMOC as a massive conveyor belt, powered by water's temperature and saltiness. Warm, salty water travels north from the tropics, releasing heat near Europe and making the region livable. As it cools, the water becomes dense and sinks, plunging to the ocean's depths before flowing southward. This deep current eventually resurfaces elsewhere, completing a global cycle that takes centuries. The AMOC doesn't just move water, it distributes heat, nutrients, and helps absorb carbon dioxide. The sinking in the North Atlantic is the engine of this system. If it weakens, the entire conveyor slows, with global consequences. For years, the AMOC seemed unshakable, but recent data tells a different story. Proxy records show the AMOC is now at its weakest in over 1,000 years, with a 15% decline since the mid-20th century. A persistent cold blob south of Greenland signals less warm water reaching the north, a clear sign of change. Some studies warn a collapse could happen as soon as this decade, though the exact timing is debated. What's certain, the risk is real, and the AMOC's stability is more fragile than we once believed. The AMOC's slowdown is being driven by human-caused climate change, a force that is reshaping the very systems that keep our planet in balance. The Atlantic Meridional Overturning Circulation, or AMOC, acts like a giant conveyor belt, moving warm water north and cold water south, regulating temperatures and weather patterns across continents. But now, this vital ocean engine is sputtering, and the reasons are deeply connected to our actions. as global temperatures rise, Greenland's vast ice sheets are melting at an unprecedented rate. This meltwater pours into the North Atlantic, adding huge amounts of fresh water to the ocean. The influx of fresh water dilutes the salty seawater, making it lighter and less likely to sink to the ocean depths, a crucial step in the AMOC's circulation. When this sinking slows, the entire conveyor belt weakens. The engine that powers the AMOC is thrown off balance, and a dangerous feedback loop begins. Less sinking means less salty water is pulled northward, which further weakens the system. This self-reinforcing cycle threatens to destabilize the climate patterns we depend on. Scientists call this the salt advection feedback. If this process continues unchecked, it could push the AMOC past a critical tipping point, a point of no return where the system collapses, with potentially catastrophic consequences for weather, sea levels, and marine life. Our relentless greenhouse gas emissions are fueling this process. Every ton of carbon dioxide released into the atmosphere traps more heat, accelerating ice melt and ocean disruption. The link between our fossil fuel use and the AMOC's decline is direct and undeniable. One of the most striking signs of this disruption is the so-called cold blob in the North Atlantic, a patch of unusually cold water that stands out in a warming world. This anomaly is a fingerprint of the AMOC's weakening, a warning sign from the ocean itself. The health of the AMOC is a direct reflection of our planet's overall health. When this system falters, it sends shockwaves through marine ecosystems, coastal communities, and global weather patterns, threatening food security and biodiversity. Scientists around the world are racing to understand these changes, deploying advanced technology to monitor the ocean's vital signs. But the truth is, we are running a dangerous experiment with Earth's climate engine, one whose outcome is still uncertain. The consequences of inaction are becoming impossible to ignore. Extreme weather, rising seas, and ecosystem collapse are no longer distant threats. They are happening now, and the time to act is running out. If the AMOC collapses, the effects would be swift and severe. This isn't just a distant scientific concern. It's a real and immediate threat to the stability of our climate, our societies, and the natural world as we know it. Europe could see winter temperatures drop by up to 10 degrees C, plunging cities into deep freezes not seen in centuries. Storms would become more frequent and more violent, battering coastlines and infrastructure. Agriculture would suffer as growing seasons shorten and crops fail, threatening food security for millions. The northern hemisphere would cool dramatically, while the southern hemisphere heats up, creating a stark imbalance. This shift would disrupt established weather patterns, leading to unpredictable seasons and extreme weather events across the globe. Rain belts could move, causing devastating droughts in the Amazon and Africa, while other regions face relentless floods. Entire ecosystems would be thrown into chaos, with plants and animals struggling to adapt to the new climate reality. Sea levels along the US East Coast and Western Europe could rise by up to 70 centimeters, enough to inundate major cities, displace millions, and cause billions in damages. Coastal communities would face chronic flooding, eroding shorelines, and the loss of vital infrastructure. The AMOC also helps store carbon dioxide in the deep ocean. Its collapse would leave more CO2 in the atmosphere, accelerating global warming. This would make it even harder to keep temperatures in check, pushing us closer to dangerous climate tipping points. This feedback loop would amplify climate change, melting glaciers and ice sheets even faster, and fueling more wildfires, droughts, and heat waves. The impacts would be felt everywhere, from the poles to the equator. The chemistry of our oceans and atmosphere would be fundamentally altered, affecting everything from the air we breathe to the water we drink. Ocean acidification and pollution would threaten marine life and fisheries, while air quality could worsen in many regions. The AMOC's collapse would reshape life on Earth, forcing people, animals, and entire ecosystems to adapt or perish. The world as we know it would be transformed, with consequences that could last for generations. The stakes could not be higher. Our choices today will determine whether we face this future or whether we act in time to prevent it. The Gulf Stream and the AMOC are often confused, but they're not the same. The Gulf Stream is a fast, warm surface current that helps keep Europe mild. It's just one visible part of the much larger, deeper AMOC system. The Gulf Stream is wind-driven and will likely keep flowing even if the AMOC collapses. But without the AMOC's pull, the Gulf Stream's warmth won't reach as far north. Europe would lose its mild winters, as heat stalls in the mid-Atlantic. Understanding this difference is crucial to grasping what's at risk. Scientists monitor the AMOC with networks of ocean floor instruments like the Rapid Array and OSNAP. These tools measure water speed, temperature, and salinity, providing a real-time health check for the circulation. Satellite data adds another layer, helping track changes over time. Researchers look for early warning signs, like increased fluctuations or slower recovery from disturbances. A decline in deep water mixing could signal the AMOC is nearing collapse. Continuous monitoring is our best hope for advance warning. These observations refine climate models and guide global action. The data is vital, our window into the ocean's heartbeat and our planet's future. The AMOC has collapsed before, with dramatic results. Ice and sediment cores reveal that during the last ice age, abrupt climate shifts were linked to AMOC instability. The Younger Dryas, 12,800 years ago, saw a massive freshwater influx shut down the AMOC, plunging the northern hemisphere into a deep freeze for over 1,000 years. Temperatures in Greenland dropped by up to 15 degrees C in just a decade. Today's changes are happening even faster, driven by human activity. The past shows the AMOC is sensitive and vulnerable. History warns us. Climate stability is not guaranteed. If the AMOC collapses, restarting it would be extremely difficult. The system exhibits hysteresis. Simply reversing the cause isn't enough. Conditions must improve far beyond the original threshold. Past collapses took centuries to recover, locking the world into a new climate for generations. Some models suggest a brief window for recovery if freshwater input is rapidly reduced, but this would require unprecedented global action. The best solution is prevention. Cut greenhouse gas emissions and slow ice melt. Every bit of warming avoided reduces the risk. The AMOC's fate is in our hands. Our choices now will shape the climate for centuries to come.